Derek Hahn. I'm the Chief Architect of the Advanced Analytics Lab at BAE Systems, where we design, deploy, and develop automated solutions and robotic process automation that helps customers find optimizations and improved analytics at speed and scale. My talk today is about how development operations in its traditional form do not fully support everything that is required in developing machine learning models. However, I do believe that paradigm can be adapted to support faster, smarter, more accurate machine learning models at speed and scale. Before I start, let me define what I'm talking about whenever I say a machine learning model. A lot of data scientists get into arguments with each other about what exactly is machine learning, what is a machine learning model, what is statistics, what is AI. And so for the sake of this talk, I get to set the terms since I'm the one presenting. I'm going to be defining machine learning model as a software artifact that can be inserted into a development framework and produce an analytical outcome at speed and scale. With that being said, I feel like it's important to also review what exactly is important about development operations before I transition into describing how machine learning model development is empowered by this framework and paradigm. Ultimately, the entire core concept of development operations is to get a product from the keyboards of the developer into the hands of the user as soon as possible, as soon as it's available. In the same way, we want to be able to deploy a machine learning model as soon as it's able to provide a decision or analytical outcome in the same way that it would, in the same way that a worker would be able to produce the same kind of decision and effectiveness with the same accuracy and trustworthiness. Looking at the three pillars of development, DevOps business value, it's about reducing cost, reducing redundancy, making it to where you can move from the keyboard to the customer as fast as possible, keeping and improving the KPIs of what your business is trying to achieve. Our 5 pillars of software delivery automation, making it to where we are continuously improving, making it to where we're continuously delivering, that we know exactly what's in the field and where it's at, what it's able to perform, and what value it's actually able to achieve for the customer's desired outcome or a business's desired requirements. So let's talk about why I think the traditional model of DevOps does not support machine learning operations. I feel and have been exposed to that traditional development operations is about producing a single artifact or series of artifacts from the same code base. However, a machine learning model, since it is derived from varying data sources, may not have the same single source of truth or single state as the same source code would be able to achieve from a different data set. Next, I would say that the requirements of where that machine learning model needs to be deployed and where it needs to go is different. So some individuals want it deeply ingrained to where it is able to perform its statistical analysis without heavy resource contention, while others don't really care and just want it to be accessible via some kind of API that they have hand-rolled. Next, the training processes are extremely time-intensive. As most software development products go, the ETL process takes up 80% of your time and your cost and your development effort. Making the data recorded correctly, accessible, and repeatable is possibly the number one obligation of a software system. It's to move data and perform work. Lastly, it's traditional DevOps. The unit tests don't necessarily have the same requirements and desires that you would want to have for a model. Sometimes you just want to check general performance. Sometimes you want to check accuracy, precision, recall, etc. While the passing of a test for a traditional software product is binary. While machine learning models, I would argue, has a varying degree of acceptance of saying, well, it could be better, but it's at least performing the analytical outcomes that it needs to right now so we can get it to market. So before I move on, I guess that begs the question that if machine learning model development is truly different than software development, should we develop a new lifecycle? Should we throw out DevOps wholesale? And I would say no. I would say existing infrastructure can easily be adapted to support creating new models. And I'll describe that as we go now. The automation of data grooming and data set management is imperative to be able to produce models faster, support software development that utilizes the analytics from those models, and can easily be done using existing infrastructure that would take the place of implied tasks. I'm going to be using the example of data augmentation. For example, data augmentation is the idea that you can start with a small subset of data and expand it to where you get more explanatory outcomes from that data, small data set. Imagine that you're running a company that wants to be able to identify in images bicycles. You get given or you've aggregated yourself, or it doesn't matter where it came from, you have only 50 pictures of bicycles that meet your needs. You would hope that you'd be able to have more pictures of bicycles so that your model would not be shoehorned into only being able to identify such a small subset of data. You would be able to automate using the same infrastructure of most development operations to augment that data to create more data points. This would be the idea of taking those 50 pictures, stretching all 50 pictures to where instead of 50, you now have 100. You could further take those, mirror them. So now instead of having 100 pictures, you now have 200. So you can automate those as opposed to forcing some intern or somebody else to run a script that incrementally augments that data and quickly expand it into something that will provide better value. Furthering the strategy of data grooming and data management, you can automate general model performance based off of data sets that are either publicly available now or proprietary data that y'all have collected yourselves. An example of this would be the COCO Common Objects in Context data set, which can easily be used to check general model performance for early development stages of a model. And lastly, having an automated collection strategy easily produces records that can then go back for auditing and reproduction. I'll explain in the next slide kind of how understanding and making sure that you understand those data sets are extremely important to ensuring that your product is able to provide the value that it needs to. However, I will be transitioning to a small nuance. Instead of just general machine learning, I will be talking about an optimization that can be found in deep learning. And this is the idea of hyperparameter tuning via configuration management. You can hyperparameters, for example, are the knobs that can be turned to increase certain aspects of model performance up and down. You can imagine that this is the same as an oven. If you want one parameter to become hotter, you turn the knob. If you want it to be colder, you turn the knob the other way. Finding the optimal configuration of those knobs leads to better model outcomes. The two ways that this is performed is by random search or grid search. You can think of a grid search as the idea of a brute force. I'm going to try every single knob configuration that I can until I'm able to quantify the most optimal knob configuration and deploy that model. There were some academics that discussed that if you don't start from all knobs off and then try to turn them all on incrementally, that you can actually start randomly and just turn the knobs on randomly and then tune that way from your original deployment option. By running tests in parallel, as soon as source code and data sets have been identified, you can deploy a high-performing model that you've identified via random search while you still continue to find the optimal settings of those hyperparameters via grid search. This is even more important when putting into a reproducible pipeline via your DevOps infrastructure, because you want to know exactly what those parameters were and not just that a model has reached its threshold of performance. Lastly, we need to take this product to market. And the way that we do this is by making sure that we are able to produce the artifacts of the model using the data that we have aggregated into the FOSS framework that the customer wants. For example, that there are a lot of commercially available community-sourced products that are rolling their own machine learning toolkits that are strategically aligning with one of these FOSS developments. So in order to make sure that you provide support in all of those, you don't necessarily have to be developing the machine learning model inside that language, but you do have to be able to produce the artifact that your downstream customer wants. And you can do that by setting up your build paths in an efficient manner. And this allows you to version properly in the same way previously that if you found a high-performing model using random search, you can then provide that update or at an up cost or whatever your pricing structure is whenever you find the most optimal via grid search. But it's important to identify each of those features to where you're able to also check to see if there's any kind of performance loss when moving from one framework to another. For this presentation, I extensively used a lot of CloudBees white papers that were available that were very helpful in identifying what the key components and vocabulary is for the industry and communicating that business value. So I appreciate that. And thank you very much for this presentation. I'm Derek Hahn. I'm the Chief Architect of BAE Systems, the Advanced Analytics Lab. Thank you very much. Have a good day.